Hi, now I'm going to start chapter 2 for analysis 1. Uh, First topic is the polynomial function. So let me start with the formal definition of the polynomial function. A polynomial function is in the form of f of x. What is f of x? A n x raised to power n plus a n minus 1 x raised to power n minus 1 plus up to so on a2 x square plus a1 x plus a naught. So this a n belongs to set of non-zero real numbers. Or naught means we have excluded zero from set of real numbers. So a naught, a n should not be equal to zero. Rest of all others, a n minus 1, a2, a1, a naught, or belongs to set of real number. They also may be zero. Some of them may be zero. And what is n here? This exponent n minus 1, and then x square, x1. So these are belongs to n. So this is the polynomial function and its degree is n. What is the degree of polynomial? Degree of polynomial is the highest power involved in the function is the degree. Highest exponent involved in the polynomial is the degree of function f of x. So this a n x raised to power n first term, this term is called leading term of this polynomial f of x. Leading term. So what is leading term? This is a n x raised to power n. This is the leading term of the polynomial. So, and this a naught is the constant term of the polynomial. This is constant term of polynomial. This is equal to a naught, which is without x. Any term which is without x is the constant term of the polynomial. And this highest degree term in the polynomial is the leading term of the polynomial. This is the leading term of the polynomial. So, for example, this is a function uh, f of x is equal to 3x raised to power 5 minus 2x plus 7. So, 3x raised to x raised to power 5 is the leading term of the polynomial, and this is the constant term of the polynomial. Okay, now I'm going to discuss few of the examples for this polynomial function. First of all, this one, number one example, f of x is equal to 3 plus pi. So this is an example of a polynomial function. You can see that on this right hand side, there is no x involved here. So this polynomial has degree 0. Degree 0 polynomial. So this is another example of the polynomial 1 minus square root of 3x. Here exponent of x is 1. So it means that degree of this polynomial is equal to 1. So what is the degree of this polynomial? Degree of this polynomial is 2. Its degree is 2. Highest exponent in the polynomial is the degree of the polynomial. So what is, this is the third example, and now this is I of t is the fourth example. Its degree is, I of t is a polynomial in t. Now here the variable is t. So its degree is 3. Since highest power in the polynomial is 3, so degree of this polynomial is 3. Now this is fifth and last example. Uh, this is the polynomial with degree 7. and this is polynomial in S, and highest exponent of S involved in this example is 7. So degree of this polynomial is 7. So this is uh, a section for the examples of the polynomial function. You can see that these are 3 plus pi is the constant term, and this is of course a constant function. In this example, in the second example, g of x, 1 and minus square root of 3 are constants or coefficients of the polynomial. And here, in third example, coefficient is x of x square is 1, coefficient of x is 10, and this is the constant term. And here, in this case, fourth example, minus 1 is the coefficient of x cube, 1 is the coefficient of t, and minus 1 is constant term. Here, the coefficient is this. Uh, I just want to go back for a while. These are called this an minus 1, an minus a2, a1, a naught. These are called the coefficients of the polynomial. Okay. Now, I have written heading important remarks regarding the polynomial. This first remark is a polynomial function with an expression of the form ax raised to power n, with a belongs to R naught. R naught means a belongs to set of non-zero real numbers. We have excluded zero from the set of real numbers. So this function f of x is equal to ax raised to power n, where n belongs to n set of natural numbers. This also excludes zero. This is called the power function. This f of x is called power function with a natural exponent. So this natural number is the exponent. So second remark is the uh, okay. Just I'm going back to give example. This is some example of uh, power function. So now come back to the second remark. The function with expression f of x is equal to 0. This is called zero polynomial, and this function has no degree. We cannot assign any degree to this function because it has no x, and in fact this is 0 on the right side. So this is called the zero polynomial with no degree. Okay. Next is the polynomial equation. This is the polynomial equation. Polynomial equation is an equation that can be reduced to form f of x is equal to 0 with f a polynomial function. Any polynomial equation that can be reduced to the function. So that function will be called the polynomial function. The degree of the polynomial equation is the degree of the polynomial function. Uh, Polynomial function which is defined here has the degree, which is the degree of the equation. Uh, I'm just going to explain this with an example. The solution of the polynomial equation are zeros of the corresponding polynomial function. I will explain this just now with the help of an example. If the degree of the polynomial equation is at least 1, that it cannot be less than 1, then the maximum number of the solutions is equal to the degree of the equation. Okay. Uh, It is very important to explain each remark with the help of example. So I am taking this example. X raised to power 4 minus 2x square is equal to 2x square plus minus 1. So what is this? This is a polynomial equation. Polynomial equation. So now, how can we get polynomial function from this equation? If you take some f of x is equal to, you have to take 2x square and negative 1 on the left side of this equation. So what will it become? X raised to power 4 minus 2x square plus 1. So this is polynomial function. Polynomial function. So you can solve a polynomial equation like this is a polynomial equation. X raised to power 4 is equal to 2x square minus 1. So if you solve this polynomial equation, you will get these values. X is equal to 1 and x is equal to minus 1. These are the solutions of polynomial equations. These are solutions, solutions. Solutions of polynomial equations. Okay. So now this is the solution of polynomial equations. Now for polynomial function, for this polynomial function, for f of x is equal to x raised to power 4 minus 2x square plus 1. Same values, x is equal to 1 and x is equal to minus 1 are zeros of f of x. The solution of any equation will be the zeros of the polynomial functions. So now, how can we find the zeros of the function graphically? So this is example which we are discussing. If this is a function sum f of x and we draw its graph here, and the points on the graph where graph is touching the x-axis, these are actually the zeros of the graph. So what are the zeros of f of x? Zeros of f of x are actually the points where graph is touching the x-axis. So these are the zeros of function. So this is 1 and this is negative 1, which we have described here. So this x is equal to 1 and x is equal to minus 1. These are zeros of the function f of x. But if you talk about this equation, x raised to power 4 is equal to 2x square minus 1. Then for this equation, x is equal to 1 and x is equal to minus 1 are its solutions. These are its solutions. So hopefully you have very good idea of zeros of the function and solution of the equation. So this is all about for this video. Hopefully you have understand. Thank you.